Example 1. Can you predict the chemical formulas of the following compounds? Before we write down the answers of these problems, let's review the rule first. This is the rule I want you to memorize. M stands for memorizing. The rule says when 2 or more ions pair up to form an ionic compound, the net charge of the compound must be equal to 0. And the net charge is equal to the sum of the positive charges and the negative charges. I want to emphasize that the positive charges are positive numbers and the negative charges are negative numbers. That's how you can make the sum equal to 0. From this rule, we can draw 3 conclusions. Conclusion A. Cations must pair up with anions to form an ionic compound. Conclusion B. Cations cannot pair up with cations to form an ionic compound because the sum of 2 or more positive numbers cannot be equal to 0. Conclusion C. Anions cannot pair up with anions to form an ionic compound because the sum of 2 or more negative numbers cannot be 0. When you write down the chemical formula of an ionic compound, generally you need to put down the cations before the anions. This is another rule to write down the chemical formula of an ionic compound. Generally, we should put down the cations in front of the anions. But I should let you know there are some exceptions. In some compounds, anions are in front of the cations. But this rule applies to 99% of the ionic compounds. Now let's apply the rules to find the answers of these problems. Problem A. An ionic compound formed between aluminum and nitrogen. First, we need to use a periodic table to find the charges of the most stable ions of aluminum and nitrogen. From the periodic table, the charge of the most stable ion of aluminum is +3. The charge of the most stable ion of nitrogen is -3. The charges of the most stable ions of the elements are something you have to memorize. Next, we need to switch the 2 numbers. What I mean is we will place this number, which belongs to nitrogen, at the bottom right corner of aluminum. And we need to place the number here, which belongs to aluminum, at the bottom right corner of nitrogen. Remember, only write down the numbers. Do not copy down the signs. Then what we need to do is to find the smallest whole number ratios between these 2 numbers, which is 1 to 1. The rule says if the number at the bottom right corner of the element is 1, you have to omit that number. This will be our final answer. I want to emphasize during an exam or a quiz, this is all I need. You do not need to show this part. Problem B. An ionic compound formed between oxygen and calcium. Let's look at the periodic table. The charge of the most stable ion of oxygen is -2. The charge of the most stable ion of calcium is +2. The rule says when you write down the chemical formula of an ionic compound, you should put down the cation in front of the anion. So let's switch them. Then we need to switch the 2 numbers. The next step is to find the smallest whole number ratios between these 2 numbers. The rule says if the number at the bottom right corner of the element is 1, we have to omit that number. This will be our final answer. As I said earlier, during exam or a quiz, this is all I need. You do not need to show this part. But this shows you how you get the answer step by step. Problem C. An ionic compound between chlorine and magnesium. Let's find the charges of the most stable ions of chlorine and magnesium from the periodic table. From the periodic table, the charge of the most stable ion of chlorine is -1. The charge of the most stable ion of magnesium is +2. The rule says when you write down the chemical formula of an ionic compound, you put the cation in front of the anion. Then we need to switch the two numbers. And the rule says if the number at bottom right corner of the element is 1, we have to omit that number. This will be our final answer for problem C. Problem D, an ionic compound between Fe and Br. From the periodic table, Fe is the transition metal. As we have learned in class, we cannot predict the charge of the most stable ions of the transition metals. Therefore, we cannot predict the chemical formula of this ionic compound.